the full pattern looks something like this. So you've got this main central peak, which, as I said before, contains almost all the energy, and then just some little wiggles off to the side here, which are almost never of any real importance. So really what we care about is this angle theta to the first minimum. All right, so now let's put the two effects together. That is, let's do a two-slit interference experiment, but now we're going to have the slits be of finite width. So here's the barrier, and here is my observation screen. And imagine that I've got my incoming plane wave like so. And let's say I cover up this bottom slit so that only the top slit can get through. I'm going to get an interference or a diffraction pattern due to just that top slit, which would be centered on this point. So that would be something like this, the one slit diffraction pattern. If instead I cover just the bottom slit, or sorry, just if I cover the top slit so I can see the pattern just the bottom slit, I would also see an interference pattern centered on the bottom slit. Something like this, a diffraction pattern centered on the bottom slit. Now, in real life, these two slits, for most experiments, their separation is very, very small, maybe about 0.1 millimeters or something like that. And this angle, although it's a small angle, let's say if we're finding the angle to the first minimum, it's small, still the observation screen is far apart. So usually the size of these patterns is of the order centimeters. So I haven't really drawn things to scale very well. If I had the diffraction pattern due to just the bottom slit and the diffraction pattern due to just the top slit, they would really overlap. So a more correct drawing would be, I've got these two slits. They're very, very close together in real life. And so the two patterns, let's say here's the pattern due to just the top slit, and here's the pattern due to just the bottom slit, be only very slightly displaced. So it'd be displaced by such a small amount that it'd be quite hard to measure, because the displacement between those two patterns is of the order of only 0.1 millimeters, and this is several centimeters, the extent. So now those two, now let's open up both slits simultaneously for the first time. That overall intensity pattern due to the single slit diffraction is still present, but now superposed on that, we have the possibility for two-slit interference. That is, there can be places within this pattern where the light coming from the bottom slit is in phase with the light from the top slit, and so we get very strong intensity there. And there can be other places where they're out of phase, and the math for that is all the same as what we worked before, but now it's superposed on this single slit diffraction pattern. So the resulting pattern that you would get is the product of the two. So if I take the single slit pattern like this, and then I multiply that by the two slit pattern. So it's like this, but let's say maybe here's a point where the light from the two slits is out of phase, so that would cause a dip in the intensity. So it's this multiplied times the two slit pattern, which looks like that. If I take the product of those two functions, I'm going to get something that sort of has these little wiggles inside the envelope of the single slit pattern. So I'm going to draw that one more time to make it a little bit more clear of how it might look. I'm going to use, let's use slits that are closer together this time, so that the the little oscillations inside are faster. So the pattern that you'd observe would be something like this. And again, the angle to, let's say, this first peak, this is the m equals 0, the straight ahead, m equals 1. I still use the same equation, that d sine theta equals m lambda, to find the positions of each of these peaks within the pattern. And then if I want to find where is this minimum in the overall diffraction pattern, I can just use the formula that we talked about before, that 3-star formula, that theta of the first min is equal to lambda over A.